Okay, today, yeah, it's still dark out, it's still raining, so I thought we would do another balancing. Um, sorry, I ran out of room right here, but I'll fix it later. Um, this is going to be an net-ionic equation. So you see that we have two um, ionic compounds. We have potassium chloride and lead nitrate. And they're AQ, so they're both soluble in water. And then, but when we put them together, we get potassium nitrate, KNO3. That's a 3 that looks like a 2 on the video. So you get potassium nitrate, KNO3, and lead chloride, which you see here by the S forms a precipitate, so it like falls out of solution. So there is what drives the reaction, the formation of that precipitate. And since it kind of falls out of the reaction, making a solid, it just keeps going. And so the reaction always moves kind of towards a forward, and it has a K that is much, much greater than 1. We'll talk about that later. But rest assured, this reaction happens. It happens relatively quickly, and we get a lot of product out of it. And the product is lead chloride, which is like this silty white powder. So the first thing I want to do is I want to balance the equation. And so when I look at the equation, I notice that I've got a 2 in front of this potassium, and I got a 2 chloride here because it's lead 2, so it's PbCl2, but I've only got 1 chloride here. Easy fix. I'm just going to put a 2 there, and then that kind of fixes it at that point. This is a really easy balance, because actually I think I shouldn't have had that there at the beginning, but I got this from a balanced example. So just basically make sure your reaction is balanced. That's the important part, okay? So now in a balanced reaction, I've got 2 potassium chloride plus lead 2 nitrate. When you mix them together, you get 2 potassium nitrate and the lead chloride precipitate. Okay, now since I balanced it, the first thing I want to do is like a full ionic equation, so I have to split everything up, and I might have to write kind of small, so bear with me. So KCl is K plus 1, Cl negative 1, but I have 2K plus 1 AQ plus 2 Cl negative. I'm not going to have enough room, so I'm going to do reactants on one line and products on the other. And then I've got Pb plus 2 AQ plus 2NO3 AQ. Wow, that's a ton. So I have split up all my reactants. So you see that since I have 2 of these, I need 2 of the K positives, 2 of the Cl negatives. I only have 1 lead, so I don't put a 2 in front of that. But I do have 2 of the nitrates, so I need to put a 2 in front of that. Now for my products, it's a little easier because I've got 2 potassiums, I've got 2 nitrates, and then the lead chloride, because it's a solid, it stays together. Okay? So these are my products right here, reactants, products. And then what I need to do is figure out what is on both the product and reactant side. Now the first thing I notice is that potassium, 2K+, is a reactant and it's a product. So I'm going to cross off my potassium. I also notice that the nitrate is here as a reactant and here as a product, so I cross it off. Which leaves me 2 chloride ions, a lead 2 ion, and then my precipitate, lead chloride. The reason why I crossed off these guys is they don't really take part in the reaction. They start in solution and they end in solution. They're known as spectator ions. Spectators. They just watch. They don't do anything. They don't form a precipitate. They don't get evolved as a gas. Nothing special happens with them. So that's why they get crossed off. Now all I do is I rewrite my equation. Usually we write, when we're doing a net ionic equation, and this is after we've crossed out the spectators, we do it just like we would do a formula with the metal first and the anion second, whatever that anion is. So Pb plus 2 Aq, when mixed with 2 chloride ions, Aq, yields lead 2 chloride, which is a solid. Boom, right here. So if you want that in words, when potassium chloride is mixed with lead nitrate, a precipitate of lead 2 chloride forms.